So, mole problems with an equation, super important in chemistry because this is how you figure out how much reactant you need to make a certain amount of product under the conditions of STP. Remember, this product that you make, if you find out the amount you're going to make, it's theoretical. Then you can compare it with how much you make in lab itself. Then you can find the percent error. So, the last video, we did 1 and 2 step mole problems. How to get into moles, how to get out of moles. There are 2 ways to do mole problems with equations, such as this equation in making ammonia. You can do factor label or you can do ratio. I teach my students the ratio because in the equilibrium chapter, you know if whatever's done to one side must be done to the other, so the ratio remains constant. So let's check this out. This is the easiest type of question. This is a mole to mole. So, a mole to mole, you don't have to get into moles and you don't have to get out of moles. You just have to find the ratio. So the first thing you have to do is, okay, I'm using ammonia and I'm using nitrogen gas. So what I'm not using, I tell my students to cross out. I'm not using, even though it says hydrogen, hydrogen is not being found and is not being given, so we cross hydrogen out. The next step is this. Whatever the coefficients are in the 2 substances you're using, drop them below it. This is 1, so we put a 1 below that. Ammonia is 2, we put a 2 below that. That's how we start out. Then, 0.5 moles of nitrogen gas. It's got to be moles on top, so I go like this. 0.5 moles. I am looking for moles of ammonia, so this is X moles. So that's it. There's my ratio. So it's 0.5 over 1 equals X moles over 2. So X equals 1. X equals 1 mole of NH3. But this one you could do without any ratio at all because watch. The given is 1 mole of N2. But if I cut that in half there, then that's going to be cut in half, so that goes to 1. So that's why I like this ratio thing. But remember, mole to mole is absolutely the easiest because you don't have to get into moles and you don't have to get out of moles. Now we'll do one where you have to get in and out of moles. Okay, so we're using the same formula. N2 plus 3H2 yields 2NH3, and here's the question. I have 6 grams of hydrogen gas, so I'm using hydrogen gas, so I would drop the 3. Produced how many liters of ammonia? So I'm using ammonia, I'm going to put a 2 there. Now, what I'm not using is I'm not using nitrogen. So I cross nitrogen out. Now, I can't put 6 grams above the hydrogen. It must be moles. So to use the ratio in a mole equation, you got to have moles. You can't have liters, grams, or molecules on top. So remember, if I give you grams, you must divide by the molar mass to get moles. So that 6 grams would be divided by 2 grams, and I get 3 moles. So I put 3 up on top. Now, I'm going to find moles. That's what you always find in a ratio. So it's going to be X moles. So here's your ratio. It's 3 over 3 equals X over 2. So it will be 3X equals 6. So X equals 2. But remember, that's 2 moles of ammonia. I don't want my answer in moles. I want it in liters of ammonia. So now we have to get out of moles. And remember, if you want to get out of moles, you either multiply by 22.4 to find liters, molar mass to find grams, or 6.02 times 10 to the 23rd to find molecules or atoms. So all I do is I take that 2 moles and I multiply it by 22.4, and I come out with my answer, which is 44.8 liters of ammonia. Okay, that's a good one. Remember, if I give you grams, you got to find moles, put it on top. If I want to find liters, you have to find moles and then convert to liters. All right, let's do another one. Okay, this is a little bit different. 3.01 times 10 to the 23rd molecules of ammonia decompose into hydrogen gas and how many grams of nitrogen? So I am using ammonia again, and I'm using nitrogen. So what I'm not using is hydrogen. Cross the hydrogen out. Since I'm using ammonia, I'm going to drop the coefficient 2, and nitrogen, drop the coefficient 1. Now, this is a molecule to gram, all right? This is a little bit tougher. So remember, I can't put 3.01 times 10 to the 23rd molecules above ammonia. It must be moles. So I take the 3.01 times 10 to the 23rd, and to get into moles, I have to divide by 1 mole of molecules, which is 6.02 times 10 to the 23rd. And notice, if the powers are the same, you can cross them out. 10 to the 23rd, 10 to the 23rd, 3 divided by 6 is 0.5 moles. So I can put 0.5 moles above here. Now, I'm going to go for my ratio. Before I do the ratio, that's what I'm looking for. Nitrogen gas, so I have to put X above nitrogen gas. So the ratio will be X over 1 equals 0.5 over 2. So what that means is I have 2X equals 0.5. So X must equal 0.25 moles of N2. So I found out that X is 0.25 moles of N2. Well, I don't want moles. The question wants to know how many grams of nitrogen gas. So I have to get out of moles. So in order to get out of moles, I simply go like this, 0.25 times whatever the molar mass of nitrogen gas is. This is where my students make a lot of mistakes because they say 14. It's N2. It's a diatomic gas, so it's 28, not 14. So 0.25 times 28. So it's 1/4 of a mole. So this equals 7 grams of N2. So this was a molecule to gram. I had to convert my molecules into moles, and then once I got moles, I had to convert that to grams. So that's a pretty tough one. We'll do 2 more. All right. Remember, all of these are under the conditions of STP because these are theoretical values that we're going to get. So I am using potassium chlorate and oxygen. So what I can do, potassium chlorate and oxygen, I can cross out that. And now I can drop, let's do this, I can drop the 2, I can drop the 3, and then 64 grams of oxygen gas. Well, you can't put grams up there, you must convert to moles. And remember, you should have memorized O2 is 32 grams. So I have 64 grams divided by 32 grams, and that is 2 moles. So what I do is I put 2 moles above O2. Then I have to put X moles here. Then I want my ratio. X over 2 equals 2 over 3. So that will be 3x equals 4. 3x equals 4, so x equals 4/3. So 4/3 is what is above KClO3. Now that's 4/3 mole. So what do I have to do now? This equals 1.33 moles of KClO3. But I don't want moles of KClO3, I want grams. So what do I have to do is I have to find the molar mass of potassium chlorate, and that's 122 grams. So now I go 1.33 moles potassium chlorate times 122 grams. And that equals about 163 grams. So there is my answer. So the big deal is this. If it's not mole to mole, you have to get into moles and get out of moles. Okay? That's why the previous video showed you getting in and out of moles. Okay? All right. We're good.